Hi everyone. So in this recording I will be solving again one question from midterm examination of game theory which was asked at Delhi University, Delhi School of Economics in 2023. Okay. So this is the question for the given statement below. Identify as true or false. Give proof or counterexample for your answer. Attempt anyone. And hopefully we will attempt both the parts in this recording. Now, so the first one is there can be no Nash equilibrium in which one player plays a pure strategy and the other mixes. The answer is false, and I will give you the reason. Okay, this is false. And if only a single strategy profile S survives iterated elimination of strictly dominated strategy, then S is the pure Nash equilibrium of the game. This is true, but we have to give the reasonings. Okay. Now, let me move for the first. Hmm. So, consider this game. This is W, this is Z for player 2, and this is X, and this is Y for player 1. Let me write it up. This is player 1, this is player 2. Okay. Now, suppose the payoffs are given as follows 3, comma 2, and this is 1, comma 2. Okay. This is 0, comma 1, and this is 2, comma 1. Now, let us calculate the payoffs for player 1 when he is playing X and the another player, which means the player 2 is playing mixed strategy. Let me give the probability. This is Q, this is 1 minus Q, this is with probability P, and this is with 1 minus P. Okay, so what will happen? 3 into Q plus 0 into 1 minus q, which makes no sense. So it will be 3q only. Utility of player 1 when he is playing y and given the other player is mixing. So it will be 1 into q. Okay, this is multiplied by 1 into q plus 2 into 2 in this 2 into 1 minus q. So this will become 2 minus 2q. So this will become minus q, right? Okay. Now let's check for player 2. So player 1 is mixing and he is playing W. So it will become what? 2 into P, 2 into 1 minus P, which will become 2 only, right? Utility of 2 when player 1 is mixing and he is playing Z. Then again 1 into P plus 1 minus P, which will become 1. So it is strictly dominated, right? He is strictly getting higher payoff. So he will never consider this. So what is the Nash equilibrium here? Depending on the Q value. So player 1 will play X if 3Q is greater than equal to 2 minus Q. Okay. So which means if it goes here, then it will become 4Q greater than equal to 2Q greater than equal to half. So what is the mixed strategy? This is with half probability he will play X, and with half probability he will play player 1 will play what? Y. But player 2 is playing a pure strategy game, no mixing. With probability 1 he will play with probability 1 he will play W, with probability 0 he will play Z. So we have shown there can be Nash equilibrium in which one player plays a pure strategy and other mixes. Okay, now the second part. Hmm. So how to go about it? So we will use a method of contradiction. Okay, I hope you read it, the question. Mm, maybe on the next page. Let me do it. So now let's assume let S star, okay, be a unique strategy that survives IESDS. So this is iterated elimination of a strictly dominated strategy. Okay. And here the strategy profile is such: S star is equal to S1, S2, star. Okay. And then Sn star. This is my strategy profile. Now the main game starts here without loss of generality. Okay. Assume S let S dash is another strategy profile which contains this. Okay. S2 star and so on. Sn star, that gives the Nash equilibrium of this game. Hmm. So in the beginning we have assumed that S star is our unique strategy that has survived IESDS. Now we are saying let us take another strategy profile S dash and we call it as Nash equilibrium of this game. So which means that utility which has been derived from S1 should be greater than or equal to utility which has been derived from S star, right? So this implies S dash is weakly because I have taken greater than equal to sign. If you have taken strictly, then it would have been strictly dominated. S dash is weakly dominate. Uh, this implies S dash weakly dominates the strategy S star. Okay, but uh, now what will happen? So this implies again this that S star is not unique survivor of IESDS. But this is a contradiction. Are you getting? I know this is a bit confusing, but we have assumed S star to be unique strategy that survive IESDS. Then we assumed one more thing without loss of generality. There is some another strategy which gives the Nash equilibrium, and if it is giving, then this means that it is weakly dominating, but it has contradicted our initial assumption. So this implies contradiction. Therefore, S star is a unique strategy that survives IESDS. Then S star is the unique pure strategy Nash equilibrium. That's all. Thank you so much.